Hi everyone, here are your notes for section 6.6. Yes, we're moving backwards, but that's okay, we can handle it. So what 6.6 gets us into are different types of triangle proportionality theorems. So please take a moment, pause this video when you need to. I'm just going to kind of read right through it and assume that you are going to pause yourself. So your triangle proportionality theorem states if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So what does that mean? If we have a triangle, so here's my triangle, and I have a line that is parallel to one of the sides. So let's say this line right here is parallel to the third side of my triangle. Then what happens is it splits it into proportional pieces. So I have the top half highlighted in green and the bottom half highlighted in pink. So what I could do is I could create proportions where, remember, proportion is two fractions equal to each other, where I put the greens on the numerators on the top and the pink parts on the bottom, right? So green over pink equals green over pink. Green over pink equals green over pink. All right, so let's put it into practice. So find the value of x. We have a line that is parallel. I'm going to stick to my color. So I've got my two sections of green, and then we've got our two sections of pink, right? So I can make two fractions and set them equal to create a proportion. So I'm going to do my greens on top and my pinks in the numerator. So green in the numerator, pinks in the denominator. So what numbers go there? So I have an x and a 5, and I have a 16 and a 10. Well, we can easily cross multiply that. 10x is equal to 16 times 5 is 80, so x is equal to 8. Simple as that. I like to say, write it as you see it. Write it as you see it. Like, do you see how the physical ratios are there? X is over 16, 5 is over 10. Just set them equal, right? Just write it as you see it. Don't make it any harder than that. So now we're going to flip the switch. Now I'm going to be given the side lengths, and we need to determine whether those given side lengths mean that my lines are parallel. So for this to be parallel, we need to have this over this be equal to this over this. So we need to check that. So the question is 8 over 5 equal to 12 over 7.5? That's what we need to ask ourselves. If it is, then we would say, yeah, they're parallel. If they're not, then we would say no. So how do we check if they're equal? Just divide them on our calculators. 8 divided by 5 is 1.6. 12 divided by 7.5 is 1.6. So since they are, we would say yes, they are parallel. If those were not the same decimal, then we would say no, they're not parallel. But it's important to show this work. Instead, you have a 50-50 guess of just guessing it right. All right, our next theorem that we have states that if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So again, you've got 3 lines that are going to be parallel. So this line's parallel to this line's parallel to that line. They're all parallel to each other. You've got 2 lines that are transversals, so that just means they intersect the lines. But do you see how it creates proportional parts? So here's your green, and then here's your pink. So we can create proportions again of pinks being in the denominator and greens being in the numerator. So write it as you see it, green over pink, green over pink. So for this example, we need to solve for both x and y. To get our x first, I'm going to ignore this whole top half and write it as we see it. So here I have my greens on top, I got my pinks on the bottom, green over pink, green over pink. So 15 over x equals 26 over 30. 15 times 30 is 450. 26 times x is 26x. Divide that out. Gets me x is equal to 17. Oop, I'm just going to leave that. That's an ugly number. Yeah, why not? 17.31 if I go to 2 decimal places. Now if I bring back that top half to get our y, so ignore this, Now I'm going to put my pinks on top. Now I'm going to do 16.5 over 15 is equal to y over 26. Just write it as you see it. So 16.5 times 26 is 429 equals 15y. Divide by 15 gets us 28.6. So there's your x, so there's your y. Write it as you see it. Okay, you could technically you could have went this, this, and then this over this, like this way. So I could have done 16.5 over y equals 15 over 26. That would work too. But I physically see 16.5 over the 15. All right, and last one, if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So let me do this in practice. So if a ray bisects an angle of a triangle, see here's a triangle, here's my ray bisecting an angle. So bisecting means, remember, it cuts it in half. So then it divides the opposite sides into two segments. So where are my two segments? Right here and right here. Those are going to be proportional with the other sides of the triangle, so here and here. So again, we're going to set up a proportion, and we can do green over pink is equal to green over pink. So green over pink is equal to green over pink. Or we could do pink over green is equal to pink over green. Or we could do green over green is equal to pink over pink. Either combo works. So let's go ahead and find the value of x here. So here are your proportional sides. So here are my pinks. Here are my greens. Let's make a fraction. So I'm going to do pink over green. Why not? So 6 over 5, so this pink over that green, is equal to this pink over that green, x over 8. When I cross multiply that, I get 5x is equal to 48. Dividing by 5 gets us 9.6. Is our answer for x. Okay, I could have done 6 over x is equal to 5 over 8. That would have gotten me to the same answer. I could have done 5 over 6 is equal to 8 over x. That would have gotten me to the same answer. Okay, but you just make sure that it's consistent with how you're doing it. All right, that concludes your notes.